So, welcome again to our channel. And this is going to be the second tutorial for Python series. And today we are going to start with operators. So, what are operators? So, operators are the signs or the symbols that are used to perform some operations or computations on some variables or numbers, whatever there are. And there is so operators are those things. As we study in mathematics, the operators are like addition. For addition there is plus, for subtraction there is minus, multiplication, division. So these are the operations, and the symbols that we use for them are the operators. So in Python programming, there are many operators. So we will be seeing those operators. So first operator is arithmetic operators. So arithmetic operators are simple operators like addition, subtraction, multiplication, division, floor division, modulus, and exponential. You must have familiar with addition, subtraction, multiplication, and division, but these three might be new for you. So I'll be teaching these three as well. So let's get started in our VS Code. So our first operator is arithmetic operator. And operators are like these operators are like addition, subtraction, multiplication, division, etc. So let's see the first one. Let's take an example. X equals to 10, y equals to 20. And let's perform something like x plus y. And then we will run it. As you can see, there is nothing. Means we need to write the print statement, the print function. Sorry. Without writing print, we cannot show the output. As you can see, here's the result 30. So this is plus addition operator. Next, what will we do is print x minus y, and then we will run it. This is minus 10 because x is 10 and we are subtracting 20 from it, so we will get minus 10. Or what we can do is y minus x, and we will run it. See, we are getting 10. You're understanding? So this is so simple, just like our mathematics. This is mathematics, guys, not just like mathematics. This is mathematics. Let's see the multiplication. For multiplication, guys, let me tell you, we do not use the this symbol. What do we say? We do not use this symbol. This symbol we use in mathematics, but in programming, we are going to use this symbol. I mean, sorry for the bad drawing. I mean, the star symbol we will be using for our multiplication purpose. So x star y means x multiply y, and this will result in 200. So let's cancel these all and let's run it. See, 200. Now let's divide it. So as you can see, 10 divided by 20, what will it return? Can you guess? 0.5. Yes. What if we do y divided by x? It is 2.0. So this is the division of our numbers. So let's see our next operator, that is floor division. So for floor division, let me tell you one new concept in this. Let's run it first. See, here we are getting 2. So what is floor division? Let me explain you. So floor division is like when we do some division, okay? When we do some division like this, and there is a number like 10, okay? We are dividing it by 2. Then what will we do? 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8, and 2 fives are 10. So I will divide it, and the remainder that I will get is 0. Okay. There is nothing here. So the remainder here is 0. But what happens is that if, when we divide 10 by 3 like this, then we will get remainder 1. 3 threes are 9 plus 1, that is 10. Okay, so floor division is the type of division where we write our quotient of the division, we write the quotient of the division, and we do not include the remainder and all these things. So whatever the what we say, whatever the largest number here, that will be our floor division. Okay, so like let's take some more examples so that you can understand it nicely. Let's take here 100. So 7 ones are 7. Subtracting it, we will get 3. From here 0. So this is 30. We will use 7 fours are 28. And our remainder will be 2. So our floor division of this number is 14. So 100, floor division 7 is equals to 14. So I hope you all understood this thing, that what is floor division and how do we obtain floor division of a number. So like, and if you are thinking that what if we do this, like 100 floor division 10, so what will be the output? So here, as we can see, the output will be same as what the quotient is. So the quotient is 10. So 10 divided by 100 divided by 10 equals to 10. So our floor division for this thing is also 10. We are not relying on our remainder. We just want the quotient. Okay. Without any decimal points. Okay. Like we are just taking the quotient without using decimal, or uh, not in a fractional part, like it should be an integer. Okay, so that's an integer. But you might be thinking that here, when we are doing when we are dividing x by y, sorry, y by x, like this, print y divide by x, what we are getting is, let's see, what we are getting is 2.0. So in division we are getting 2.0, but in float division we are just getting an integer. It's not a decimal, it's an integer. It's not a float value. Okay. So this is how our floor division is. Next we'll be moving towards modulus. So in modulus, what do we do is, like we are doing one simple division, just like this. 2 to the 4, and the remainder is 1. So the modulus of our, see, for modulus we use this sign, guys. Percentage sign we use for our modulus. So the modulus of this 5 modulus 2 is 1. So you might have understood till now that modulus is just the remainder of any division. The remainder that we will be getting after dividing some number is the modulus. Okay, so let's see in the VS Code. Let's run it. As you can see, 20 modulus 10 equals to 0. The remainder is 0. There is nothing in the remainder, that's why the remainder is 0. Let's take something very weird, like 20 divided by 7. Let's do it. Modulus is 6. You might have understood. 7 twos are 14. 20 minus 14 equals to 6. That's why our modulus is 6 and the floor division of this number is 2. Okay. Our next operator is exponential or exponentiation. It is just like the exponent in our mathematics. So in mathematics, we used to write like 2, sorry, 2 square of 2 or cube of 2 or 2 to the power 5, 2 to the power 6. That is what we are doing here also. So in exponential power, sorry, exponent or exponentiation, what we will write is here. Let's take some small numbers so that it is easy to understand. Let's take 2 and 3. And here we will, let's take an example first. For making the square of 10, what I will write is 10 star star 2. Okay, 100. So it is just like our maths, as I already told you, like this. What we do is square of 10 is equals to 100. But here, what we write is 10 star star 2. Sorry, guys. 10 star star 2 equals to 100. Don't mind my handwriting. So this is how we will be using exponent. Let's take some more example. Like let's use these variables here. Uh, like y star star x. Let's print it. 9. So x is 3 star star 2 means 3 raised to power 2 is equals to 9. What if we exchange these two variables? 8. So 2 raised to the power 3 is 8. 2 star star 3 is 8. Okay, you're getting it. So that's it for our uh, arithmetic operators. Now we will be moving towards comparison operators. Okay, so these are like one of the most interesting things and one of the most important things that you will be doing. In comparison operator, we used to have greater than, smaller than, equals to, okay, in mathematics. But here we have some more. So uh, let's write our x equals to y. So what is this double equals to? So double equals to means we are comparing if x and y is same. If there is only single equals like this, x equals y, means we are saying that x is equal to y. But that's not the case, okay? We are just checking if x is equal to y or not. So for that, let's do it. X equals y. Let's print it. We are not getting anything. So we need to write the print function here. False. Can you see it? Here it is false. Let me clear the terminal. Run it again. You can see here false means x is not equals to y. What if we do x equals to y? Do we get some error or something? See, we are getting error. Type error, x is an invalid keyword argument for print. Means we cannot write this here. There is a type error. What is type error? I will discuss this later on. Okay. So let's check some another operators. Next operator is exclamation mark equals to. What does this mean? This means that what is the work of double equals? It is just the opposite of that. Okay. So in double equals, what we check if this is equals to this or not. But here in exclamation mark equals to means not equals to is like if this is not equals to that. Okay. If x is not equals to y. So let's check it. As you can see, our x is not equals to y. So what should it return? It should return true. That I'm saying x is not equals to y, then it is a true statement, okay? And all the answers, all the outputs that our print function will say here will be boolean values. It will be either true or false. Let's see. Here you can see true. Okay, so x exclamation mark y equals to true means x is not equals to y. Next, next is our greater than or smaller than. So let's check it. It is very simple, just like our mathematics. Let's see if x is smaller than y or not. True. 2 is smaller than 3. It's true. Let's see if x is greater than y or not. False. So you might be understanding all these things. Let's check our greater than equals to. What does this means? That either of the condition is true, then it will generate true. Okay. So either x should be equals to y or x should be greater than y. In both the conditions, our output will be true or it will be false. False, as you can see. 2 is not equal to 3 and 2 is not greater than 3. That's why we are getting false. What if we just change this thing? True. Can you guys see it? Yeah. So here is an equals to, but we are still getting true because y is greater than x. Here is a greater than symbol. So that's why we are getting true. Okay. You might have understood all four operators and comparison operators. So all these operators are correct. Okay. Like true. And here I have written comparing numbers and strings. So strings, what are strings? I might not have explained you what are strings. So let me do that also. So strings are like string is anything inside these inverted commas. Okay, the inverted commas can be one like single inverted commas or so string is anything inside these inverted commas. We can use these single inverted commas as well as these double inverted commas. Okay, so we can write something like any number or we can write some some characters. Okay, so like anything you can write inside it and it is string, and we can use all our operators, comparison operators, for this thing, that if we want to check if this string is equals to another string or not. So let's take another string name as fr and let's name it dinova. Let's take one more string name known as hr. Okay, and name it nova. Now let's check if these are valid for our comparison operators or not. Print fr equals to hr. Let's see. We are getting false. Means fr, that is the nova, is not equals to nova. Okay. Let's see if it is equals to string. False. Hr, that is nova, is not equals to the nova. Let's see here. True. That string is equals to fr. The nova is equals to the nova. So you are understanding it. You are understanding this, that we can check. We can use comparison operators for strings as well as numbers. Next are logical operators. So logical operators are like, you might have studied these operators in your class 12th science means and physics. You might have studied this logic gates and all in semiconductors. So these are logical operators and how these work, I will let you know. So let's take an example. Uh, we are checking two conditions, and the thing is that either both should be true or false, like that. Let me just write it. 3 is greater than 5 and 5 is greater than 8. So the output for this, like, is 3 greater than 5? No, so it is false. And is 5 greater than 8? No, so it is also false. So false and false will be false. Okay, so let's run it. Sorry guys, I haven't written the print. Now let's run. See, here you can see false. See, here's the false. Okay, so let's change one. still false. Let's change both. Now true. Means when both the conditions are true, then only our AND operator will print true. If any of the condition is false, then it will print false. If both the conditions are false, then it will print false. Okay, so the only condition when an AND will print true is when both the conditions are true. Okay, so let's take an example of OR. This is AND operator. Now we are using OR operator. See here, true. When both the conditions are true, then we are getting true. Same as OR, but let's see now. When one of the conditions is false, then let's see the result. It's still true. Let's change this. When one is true and another is false, it is true. But when both are true, then it will print true. Okay, so the only condition that it will print false is when both the conditions are false. In and the only condition when it prints true was when both the conditions were true, and here it prints false only when both the conditions are false. Now what is not? So for not, we are not checking anything. What we are doing is we are just printing the opposite of this thing. Okay, so if 3 is smaller than 5, so the output will be true, but here it is a not, so it will print false. See, false. Now if I'm changing it to this condition is true, this condition is false. Okay, so let's print this condition is false, and here is a not. It is printing true. Why? Because it is a false statement and we are using not before it. So it will, what will it do? It will just reverse the output. If it is true, if it is true, then it will, what it will do is it will return it to false, and if it is false, then it will do it true. So this was our logical operators. Now let's understand assignment operators. So in assignment operators, just like we assign some values to some variables like x equals to 10, then we are assigning 10 value to the variable x. So this is an assignment operator. Now let's understand all these operators one by one. You guys can see these two lines that I have written. So here I have written x equals to 10 means I am assigning a value 10 to x, means what is the value of x is equals to 10. Now what is this? X plus equals to 10. So this is like compact structure. Let's open it. So this means x equals to x plus 10. This means that whatever the value of x is, what will it be? It will be the value of x plus 10. So how can this be valid according to maths? Yeah, you might be thinking that this is incorrect according to maths, but in computer science it is totally valid. So like, let's do an example. X equals to 10, x plus equals to 10. Now I'm writing print x. Let's see what's the result. First clear the terminal. See, 20 means x equals to x plus 10. What is the previous value of x? That is 10. Now what I'm adding, x plus 10 means 10 plus 10, and now now new value of x will be 20. Means this is the initial value of 10, and whatever the printed result that we will get will be the final value of 10. And what are we doing here is we are using one operator here. The same goes in minus equals to. So it will be like x equals to 10 and x minus equals to 10. We cannot use 10 here because 10 minus 10 we will get 0. Let's use 2 here. So what will it do? The new value of x will be initial minus this. So that will be 10 minus 2. 10 minus 2 is 8. So let's see here. You can see 8. So you might have understood all these things. Now, next operator is multiply equals to. So it is just the same. We can also write this as x equals to x multiply 2. And when we will print it, the same output will be there, 20. Or we can just remove this. Sorry, syntax error. The multiplication sign will be in front. Run it. See, 20. The same goes with division as well. 5. 10 divided by 2, that is 5. It is valid for all the operators like modulus, floor division, and all. So let's do this. Floor division. We are getting 5 in integers. Let's do our modulus. We are getting 0. Let's change this so that you can understand. 7. We should get 3. See, we are getting 3. We can use this in exponential also. Let's print it. 100. So 10 raised to power 2 is equals to 100. So you might have understood all these things. Now let's move on the bitwise operator. So bitwise operator is like we can understand this thing later on, but one or two example that I must give you about bitwise operator. It is kind of similar to our logical operators. This is and, this is bitwise and, that was logical and, this is logical or, this is logical not. Here it is logical is bitwise or, here it is bitwise not. So let's see one example here. Three is not greater than 8. So this and the output for this will be false. For this will be false. So false, false, and operator, it is false. See, we can see here false. Now let's use the logic behind this is the same as logical operator. Let's use the or here. Still false because both the statements are false, both the conditions are false. So let's do one thing. Now it will be false. Why is this false? Can you guys tell? It will return false because one thing known as operators precedence. So that will be like the priority of operators, how we prioritize our operators and whose impact is bigger. Just like in mathematics, we use BODMAS, like brackets of division, multiplication, addition, subtraction, that way. So here also. After this, we will be studying our precedence order. So let's take our next operation. So for now, bitwise operator, I will be showing you this, but it is a kind of higher level. So let's take it in some next videos. Now, next is membership operator. So membership operator, either you are member of some group or you are not. Okay. So here also, like we take an example of a string, like the string is Dinova. Okay. And we want to check Nova in Dinova. Okay, we want to check if Nova is there in the Dinova. Is Nova a member of Dinova? So, yes, it is. So, it will say true. If we just, change like still true, there is an in Dinova. Now, let's take some very random things. False, because JKL is not in this word. So, it is returning false. So, this is our membership operator. There is also one more operator that is not n. So just like not equals to, it is not in. If this is not in the Nova, then it will print true. See? But if it is in the Nova, like let's say, then it will print false. Because we are saying not in and we are writing the thing that it is there, then it will return false. The next one is our identity operator. Is and not, is not, is and is not. So it will check if this is this or this is not this. So let's see. It will check if this is this false. And here it is saying that syntax warning is with string literal. Did you mean this? Means we cannot use is here for string. We can use double equals to check if d is equals to the nova. Okay, so let's take some another example for membership. Sorry, identity operator. So it just allows us to write some variables here, like we can write x and y. Let's say x equals to 9, y equals to 9. Let's print this. It is saying true, means x is y. Let's change the value. It is saying false, means x is not false. And here, what if I take any string? True. So in that case that we were doing x the nova is the nova, then it was not printing it. But this is how we will use it. What if we remove this? It is returning false. So this is how our membership operator, sorry, identity operator is. So let's take a recap of all these things. First was arithmetic operators in addition, subtraction, multiplication, division, flow division, modulus, exponentiation. Next was comparison operators, in which we saw all these symbols and operators. Next was logical operators and or not, assignment operators, bitwise operators, membership operators, in and not in, identity operator is and not is not. Let's see this is not as well. Now it will return true. As this is not this, it will return true. So let's take an example of bitwise operators that we were left with. 10 is greater than 3, 10 is greater than 3. It should be printing true. Let's see. Now what we have done is we have put one more bracket so that the precedence of this operator do not collide with each other. Now it is printing true. Now let's change. 10 is greater than 3, true. 3 is smaller than 1, false. It will return true. True. It is OR operator. Here what we can say is AND operator. You guys can see. This is true, this is false, so output is false. Let's use the NOT operator. Sorry guys. Syntax error. Then how will we be using it? Sorry guys, a very big mistake that I did was using this as not. This is not. This is for exponential power. And for not, what do we use is this. Now we are running it and we are still getting error. Is this error? Let's see. Here it is returning an error. Let's do this inside the bracket. What does it does? Now let's print it. True. Means 1 is greater than 3. This is false, but here we are using not. That is why we are getting true. So that's it for this video, in which we discussed about all the things related to operators, types of operators, and we are left with nothing. Like we covered all the operators. Next video we will learn about our operators precedence and some more interesting topics. And these videos are very basic, I know, but still we will be doing this because this is the base. If you are clear with your base, you can do anything, like anything. So signing off for this video. Thank you. You might learned a lot from it. So bye bye. Take care, and please watch the tutorial number 3. It will be there very soon. Bye guys.